Hello everyone, welcome to Computer Science E76. It's nice to see all of you again, or most of you, since some of you, it seems a little bit lighter than it was just about 5 or 6 weeks ago. So welcome to Lecture 12. This is the wrap-up lecture where I talk for a little bit about Android, David talks a little bit about iOS, and then we call it quits. And so there's a few things that we wanted to touch on today, though, in order to sort of wrap up the course, and some of them are relevant to what you really want to be doing, hopefully, when you exit this course, and that is to actually deploy some apps to the various app stores that exist today for iOS and for Android. But before we get to that point, there's a few things that we did want to talk about, and that is there's been, I'm sure you've seen in the news recently, even if you follow blogs, or even I think in the national news has picked this up, that a lot of the phone manufacturers are now catching flack for storing users' location data. And there's quite a bit of things that are interesting about this, because this was done without users really knowing about it, and it's especially in the case of iOS, it's stored in a particular file on the phone. And Google is accused of doing the same, though as far as I know there's no hard evidence of it, but I wouldn't be surprised if we actually found that there was some file that contained this same data. But basically, I'm not sure that I would be too worried about this, at least right now, just because there's no, and I'm sure David will talk more about this in the future, but especially with iOS, there's ways that you can protect your own backups, then protect the data that comes off of this phone. And even on Android, there's going to be some ways that you'll be able to protect yourself as well. And for those of you that are concerned about the authorities finding out where you were and whatnot, I'm not sure that it's really going to be any more difficult for authorities to get data like that, rather than just asking the phone company where your particular phone has been checking in. I'm sure that there's been a court case in Germany recently where somebody actually discovered that they did the equivalent of they basically just requested the records from one of the telecom companies in Germany, and they actually found months and months of their location data just from the phone company. This wasn't even local on the phone, and so there's really no technical reason why the phone companies can't store this same information on their end as well. And so just to be clear, sure, this is certainly something that is worth looking into, but perhaps not quite as bad as it might look at first blush. And with that said, location is something that is particularly interesting when we talk about mobile devices, not only because we've been working with geolocation in HTML5, and many of you probably have worked with geolocation in your own native apps for Android and iOS, but also because it can show us quite a bit of information about the operating systems themselves. And so many of you might have seen, or some of you might have seen, a visualization that came out a few months ago that actually showed all of the Android activations, the Android device activations from the beginning of Android that happened in around October of 2008 to the latest data that existed at the time of the animation, which was in January. And this is, in fact, that animation. And I think this actually shows something that's really interesting. You can really get to see how Android has, and this is specific in this case to Android, how Android really exploded, especially when certain devices became available. And so right now there's really not a lot, and you'll be able to see activations based on the height of spikes. Right now we can see it mostly in North America and in Europe, though there's a little bit over here in Eastern Asia and Japan. But pretty soon, right now, you'll see the spike, and that occurred when the first really well-marketed phone, the Droid, came out a couple of years ago now. And then the next one, the Galaxy S, will actually be happening in a couple of seconds here. And you see not so much a spike in the United States, but elsewhere in the world does it really start catching on. And I think this is sort of a neat way of really being able to see how fast Android has become a prevalent OS in the global marketplace. And so here, this is specific now to North America. This is the same data, but now we're zoomed in just to North America, and so we get to actually see now specific states and specific cities. And so these were the initial Android activations. Again, this was most likely the G1 when it came out several years ago in 2008, and we can see mostly the major city centers having activations for this particular device. But now the Droid is going to launch in a second, and all of a sudden do we see this huge spike in device activations. And we'll just keep watching this. There's only a couple of more interesting points that happen here. So here you can also see the dates of all of these activations. It happens based on a daily resolution. As you can see, we're right now in December of 2010. And now this is Europe. And so Europe, it's pretty interesting to see the differences in each of these particular markets, just because it tends to explode in one market versus another. The Droid really caught on quickly here in the United States, but perhaps not quite so much overseas, just because the marketing was done by Verizon, especially here in the States. Most likely to counter the release of the iPhone just a couple of years prior. All right, so there's only so much of this that we can take before it gets to be pretty interesting. But actually today, it was actually very convenient for me, because today Nielsen came out with a breakdown of market share for a variety of phones. And so I'd showed a similar thing earlier in the semester, but it was specific to Android. And it was a pie graph that I showed from Google that showed the number of connections, or the percentage of connections from various devices, if you remember, to the Android marketplace. Now this is different, because this actually shows a breakdown of all of the smartphones that exist in the United States today, or in the world. And so right now we can see that the market share is actually pretty well split between iOS and Android OS. But what really seems to be interesting, this is the total market share now of all of the devices that exist, that are smartphone devices in the market today. But what I think is interesting now is if we look at this same graph, but only for recent activations in the past 6 months. So what people have been buying in the past 6 months actually show that Android seems to be a stronger OS right now. And I would say that this data might be slightly skewed, it might be very temporal based, because as you know, the iPhone 4 now has been out since the middle of last year, and so people, they know about it. It's not the new hotness for what it's worth. But now Android has been, especially Verizon, has been really pushing their HTC Thunderbolt, and so there's new Android devices that are coming out all the time, and so that might be, in this case, skewing this particular data. So if we were to see the same graph, maybe in June or so, whenever Apple decides to release their iPhone 5, maybe it will actually look a little bit different. But this does actually show that Android is a force to be reckoned with. And yet another graph here, and I apologize, it's kind of difficult to read, so I'll try to zoom in a little bit. This basically just shows a breakdown when people were surveyed about what operating system, what smartphone device they wanted to purchase next. This is the breakdown of that. The blue bars represent the 6-month period between July 2010 and September 2010, and the yellow bars represent January 11th through March 11th. And so we can see now the same sort of thing where I mentioned before, perhaps the iPhone 4, the release of the iPhone 4 meant that it was the new device to have, and so the people wanting that it was much stronger feeling for that, and we can see that reflected here in the blue bar for the iOS, this portion right here, being much taller than it was for Android. But now in this most recent 3-month period, we can see that Android is in fact caught up, and it's in fact people want an Android device next, at least according to this data. So this is not really meant so much as a sales pitch, but just to remind you that these two platforms that we've worked with are the major platforms, and it's good to be able to design applications for both of them. Otherwise, you're going to be losing out on a significant percentage of the market share for your potential application. And so if you decide that you actually want to design one of your apps, or take perhaps your student project for Android to the next level and actually perhaps polish it up a little bit or complete it and actually publish it to the marketplace, realize that there's 2 major ways that you can do that. The first one we talked about before, the Android market, and this was the one that sort of it's sort of the equivalent of the App Store for Android, because this is the one that's released by Google. You have an app called the Marketplace. You can rate apps, download them, so on and so forth. But Amazon has recently come out with their own App Store as well that's also geared for Android. And so you can actually release your same application to both app stores, and people would then be able to download or purchase from either one, whichever one happens to be. And so there's upsides and downsides to both. Arguably, the Amazon one is particularly interesting just because they know how to market things to people. Like you go to Amazon.com, and based on your previous history, they might be able to recommend to you an Android application that might be useful to you. But if you actually want to deploy an app to one of these, realize that there's actually some pretty significant differences in the details that we actually need to take a look at. So the Android Marketplace, for example, if you actually want to become a developer and sell apps on there, you only have to pay a one-time $25 fee. That's not too bad. You're then a marketplace developer, and you can submit your apps to the marketplace and be able to put them up and get people to download or purchase them. Whereas the Amazon App Store is much more similar in pricing structure to the Apple App Store in that you have to buy in to a $99 per year program fee. Now, this fee is waived for the first year, so you'd be able to try it out, but I imagine you try it for the first year and you have even reasonable success, you'll be hooked in to that particular cost. Transaction fees are pretty similar. They're about 30% off the top. One of the major differences, especially for those of you that are distant to this class, between these two is the countries that you can actually make these applications available in. Right now, the Android Marketplace actually allows a great number of countries that people would be able to sell and market their applications. And compare this to Amazon App Store. Right now, you can only sell in the United States. And for better or for worse, the Android Marketplace does not have an approval process, whereas the Amazon one does. And so right now we can see all this. If you go to the Amazon App Store and actually look at the sorts of applications that are there, it's all the standard sort of stuff. Angry Birds is of course at the top of the list there, and a variety of other very common, very popular applications exist on the Amazon App Store as well. But I think it remains to be seen just how stringent this particular approval process will be in the Amazon App Store, especially as compared to Apple's own App Store. So now all of you actually had to create an application and export it. But if you, just to solidify this into something that you all have seen, if you actually have an application and you want to export it, in Eclipse, all you have to do is go to File and then Export. And rather than export an archive file, like many of you have become used to doing, you would just export an Android application. And I realized that there was some confusion about signing it, but once you pick one of the projects that you want to export, now all you have to do is just self-sign. You can basically create your own key and self-sign the application. And that's fine, that's acceptable. People will actually do that, and Google actually says that this is the standard way of distributing applications, is by creating your own private public keys and signing them with that pair. And you just have to make sure that that private key remains private to yourself. So you can actually create a new key store, which would then create a set of private and public keys for you if you just follow along with the instructions. Or if you have one, or if you already have one created, say, for your organization, you can use a pre-existing one. Yes? Right, so there's some fields that are required when you create the certificate. There's one of them is, I think there's like a name, an organization, and an address, and a variety of other things. Not all of those fields are required when you actually create a key store. The alias one, I haven't created a key store in many months now, and so I can't address that one specifically. But some of them are actually required to just create the certificates, or to create the keys. So once you sign this, you can use an existing key store. In this case, I already have one created here. Then you of course, have to enter in the password, which I'll do off screen. Then you can see the existing keys that you have. And yes, one of them is a typo, so I know one of them says CS75 lecture instead of CS76. But you can provide multiple keys within a key store for different contexts of your application. So once you provide the password for that key, which is separate from the key store, then you actually are able to create a destination APK file. And that's it. You've exported your application. You can put it on a server and have people download it directly. You can submit it to one of the app stores. Though there's going to be several steps in order for you to do that. You have to provide some artwork and a description and a variety of other things. But that's basically it for exporting and creating an Android application. Now, of course, we're trivializing the actual hard work of all of this, right? The actual creation of the native application itself. And that brings us to one of the things that we wanted to talk about today, which is PhoneGap. And so I was a little concerned, if I'm honest, about showing PhoneGap today, because then all of you will look at this stuff and say, well, why did we spend 8 weeks or 10 weeks working on the native developments if we can do all of this stuff in PhoneGap anyway? So what is PhoneGap? PhoneGap is basically just a framework that allows you to create native applications for a variety of mobile platforms using just HTML, CSS, some JavaScript, and a variety of other things. What's nice about it is that it actually exposes a variety of the hardware tools that exist on each of these phones that you would not be able to get in a typical web app. For example, the accelerometer, or the camera, or the contacts list that might exist, and anything like that that can be exposed through the native API, but not exposed through the web API, can pretty much be found in PhoneGap. Now, of course, there's a variety of reasons why you would not want to use PhoneGap. If you really had a high-performance application that you didn't want to waste time using interpreted JavaScript, then you would probably actually switch to something like to a native app. Angry Birds, just as an example, might be a little bit slower if it were implemented in HTML5 rather than actual native apps. But if you have relatively simple needs for an app, especially if it's more data-driven and not very CPU or graphics-bound, then perhaps this is something that is going to be worth exploring. And so what you do is you actually just download this thing right here, this PhoneGap button right here, links to a zip file that contains a variety of things, including a bunch of plugins for specific platforms. And what's nice is because it uses HTML, HTML5, CSS, and JavaScript, you can actually then use that same content in a variety of platforms and just recompile with all of the different, each of the specific SDKs, and they're in order to create an application for each. So David will talk about iOS in a little bit, but for now the one that we're interested in is Android. And so if we look at the contents of this Android thing, we'll see that we have a couple of things. We see that we have a PhoneGap.jar file and a PhoneGap.js file. So this is sort of, these are the links between your HTML and JavaScript and the lower level hardware or the lower level APIs that are exposed by the native development or the software development kit. So the jar file is actually that which is able to communicate with the JS file in some way and be able to provide all of that information to you. So if you want to use this, it's actually really quite easy. All you have to do is just create a new Android project in Eclipse, and you'll notice that there's a couple of extra directories that are in this project that we have not seen before. Those are the libs directory and assets/www directory. So the libs directory, just you put in the jar file and you call it a day. Then the assets www file, you put in all of your HTML, CSS, JavaScript, and also the PhoneGap.js file. Now, once you've done this, you have to notify, you have to tell your application that you're going to be using this. And so when you create, you of course have to have a Java file that's going to represent your primary activity. In this case, it's just app.java. But what we're doing here is we are extending not an activity as we have, I know you're all in iOS mind, but if you recall back to our time with Android, one of the things that we did was we created a public class that was our actual activity, and it extended the activity class. But instead, what we're doing here is extending DroidGap. And we're also adding in, we're importing up at the top, we're importing this jar file from PhoneGap themselves. So once you've done this, now you have pretty much done all that you need to do in order to load an HTML file. There's, of course, some silliness that has to be done with the manifest itself. But all of this is basically just copy-paste from the getting started portion of PhoneGap. But once you get to this point and you copy-paste all of the manifest stuff into the Android manifest file, and you create the .java file appropriate for your activity, then all you have left to do is to actually create an HTML file that then does something. And so this is just a sample app that does something really stupid. I was talking to a friend of mine and I said that I want to make an app whose sole purpose in life is to frustrate users by always making the text upside down, no matter what the angle is. And so that's what I did. then this is a PhoneGap app. Just to make the context clear, this is an application where the content that you see is written in HTML, CSS, JavaScript, but it is actually a native application, because if I bring up the task switcher here, we can see that there is that one thing. It's cut off, but it says Hello PhoneGap, which is just the native application that was built using this same thing. And in fact, the very application that we'd been previewing in Eclipse here is this same application. So now all we have to do is just create this simple HTML file, and hopefully if things are done right, what we could even do is I could pass the same HTML file over to David, and he would be able to build relatively easily a PhoneGap-based app for iOS that does this exact same thing and frustrates users on iOS as well. So here what we have is, if we can switch gears yet again from iOS to Android, and now back to HTML5 from many weeks ago. Notice that this is just a very simple HTML5 document. At the very bottom, we have just a very simple couple of tags where it just has that, it has a div with the text that says we, and you might have seen that it actually changed, but that change is based on JavaScript that's used not only for debugging, but also to make it, I don't know, marginally more interesting. But where it starts to get interesting is this JavaScript event right here, body onload. So when the body is finished loading, then we fire this function called onload, which is just a JavaScript function. And again, this is not Java. We're done with the native portion of this application. We don't have to deal with Java. We don't have to deal with intents or activities or any of that fancy stuff. We're all in JavaScript web app mode at this point. So if we go up here to the onload function, we can see that what we do is wait for PhoneGap to actually be ready. Now notice that one of the important things that you have to do to get this ready, and I will point out a sort of gotcha here like I have before, some things that tend to frustrate me a little bit. If you tend to do a lot of copy paste, especially from the getting started portions of the documentation, this is actually it was incorrect. You actually have to make sure, and it's a very obvious thing, but it took me far longer than it should have to realize that this this script source that you are including in your HTML in order to in order to make sure that you are using this JavaScript, it actually has to match the name. I think in the examples or something it was just phonegap.js, which looks totally legitimate, but actually of course it has to match the actual file name itself. So just be mindful of this gotcha, that when you include the source for PhoneGap in the HTML file, so not only do you have to do it in the native Java file, but also in the HTML file as well, so that it has access to all of the JavaScript APIs that PhoneGap actually exposes, then you have to make sure that it includes this the version number as well. So in onload, we actually added a listener to the DOM to wait for PhoneGap to finish loading. The one event that PhoneGap has is this one right here, device ready. And that event is fired when the PhoneGap JavaScript is finished loading and it's all ready to go and it's ready to connect to the native application, to the native SDK that exists at a lower level. And this event will then fire. So really, our onload, all it's supposed to do is to tell JavaScript to continue waiting its execution until device is ready. When it is ready, it will fire the onDeviceReady function. Now in that function, all we have to do is just start using the accelerometer in order to fire off some other events as soon as we have some additional data from the accelerometer. Because what we had seen in this particular application was that whenever I wanted to rotate the phone, we can see that it just uses the accelerometer to detect what the proper angle should be. So with that, we can use, with that, we can use the navigator.accelerometer.watchAcceleration, which is what happened? It shows up here, so I don't know what's going on. Let me try one thing here. Okay, good. Now it doesn't show up here, so whatever. So here we can see that we're using navigator.accelerometer.watchAcceleration, which is very similar in spirit to that to the geolocation methods, if you recall from early on in the semester, when what it would do is we would actually specify a frequency that every time there was some update to that, based on that frequency, we would actually fire a callback function. So in this case, we fire an onSuccess callback function, and that means that every time that we have a new set of acceleration or accelerometer data, which in this case is going to be every 100 milliseconds, do we fire this function and update the angle and the text within that HTML element. Yes?
Is this an extension to JavaScript, or can JavaScript on Android ordinarily monitor the accelerometer?
So PhoneGap provides extensions to JavaScript by hooking into the native portions of the code. So there's some stuff going on behind the scenes.
So there's a modification to the JavaScript interpreter somewhere.
It's not a modification to the interpreter, but because in JavaScript one of the things that you can do is actually prototype objects and classes, they are actually just using that same concept to add some additional functionality to what already exists in the browser.
So if you took a non-PhoneGap Android platform and wrote some JavaScript to try to do this, it wouldn't work.
That's right. You have to, yeah, that's right. So right now, PhoneGap requires, so in order for us to use the accelerometer, in this case, we have to use PhoneGap because PhoneGap is the method through which this becomes exposed. And I believe there's some other frameworks as well that do similar things, but PhoneGap seems to be, at least right now, the most interesting, the most mature, and it has a lot of platforms that are suited for it. So every time we have an update to the accelerometer, we run this onSuccess method, and we basically do some very basic math. In fact, it's stupidly basic. It doesn't work all the time on the data that's provided from the accelerometer. In this case, we're passed an acceleration variable. We pull the x variable, which is just what the phone detects in the direction up and down this way. And it divides it by 10, then it takes the arcs, so on and so forth, and then it actually performs a CSS transform using the WebKit transform property in CSS to actually cause an element to rotate. And that's all that this is. It's just a few lines of code, really, to write something that looks extremely frustrating to a user. Yes?
Is it possible to combine libraries? Like, I don't know, this one, the PhoneGap, and the jQuery?
You should be able to add jQuery to this, yes. I don't think there would be any reason why it wouldn't, but you would be constrained by the same constraints that you would have in a mobile web browser. So any constraints you have for jQuery or any other frameworks or libraries in a mobile browser, you also will have in this instance as well, because all it basically is doing is just loading up a mobile browser, making it essentially the size of the activity, and loading your HTML page while exposing some of these additional hardware features to your JavaScript. Any other questions? Yes?
Can PhoneGap run offline if you don't have an active connection?
Yes, that's a good question. PhoneGap can run offline because what you are doing, you'll notice that in this new folder in Eclipse, we've created an assets directory, and within it we've created a www directory, and in that we've created this index.html file. This is that file that we've been seeing here. So this is actually bundled with the application when you create an APK file. It's not actually creating a server in the sense that you would then have to have an internet access. You would then have to have internet access on the phone to be able to pull this index.html file. If you wanted to actually pull some data from the internet in your application, then yes, obviously that would require internet access. But at least the data that you embed here is actually within the application and can be used offline. Yeah?
Is the WebKit transform something that's available to standard mobile HTML, or is that being added by the PhoneGap library?
No, WebKit transform is something that is available via standard CSS. I believe you have to use the property -WebKit-transform in standard CSS, and that should work in any WebKit browser, not only for Android but also iOS and also some of the WebKit-based browsers for the browser or for the desktop as well. But in this case, we are just using the JavaScript exposes a lot of the CSS properties via methods, and this is the JavaScript method form of that CSS property. Yeah?
So the idea is for you to have in a production app, is for you to have under the www folder all the HTMLs that you will ever need. And it will locally be called out as you run without traversing
It depends on your content. So the question was, in a production app, you would probably want to include all of the HTML and content in your assets folder. Generally, yes, I suppose that would be the case. The exception would be if there's any data that actually has to be downloaded from the internet, because obviously this data will not be updated. This data will only be updated anytime you recompile the application.
Yeah, what I meant was the HTML being just like a UI of it.
Right.
Data, of course, will complement that, but all your UIs will be there in HTML.
Right. Oh, yeah. All your UI and all of your local content, yeah, should be within the assets folder here, just to make sure that it's all bundled with the same application. Mm-hmm.
Do you have documentation for the phone app?
I'm sorry?
Do they have good documentation?
Yeah, their documentation is pretty good, especially when it comes to using their APIs. In fact, their API reference actually shows you the various types of APIs that are exposed by PhoneGap. So in this case, the only one that we used was Accelerometer, but also there's other ones as well, like using the camera or the compass for phones that actually support that. Not all phones and not all OSs actually support all of these. There's a handy chart that actually tells you which is used in which case. But at least in this case, the one that we used for Accelerometer, it includes a complete list of the various methods that are exposed, and also sample functions or sample code as well that would help you get started with it. Yeah. So I think people have found PhoneGap to be pretty successful in cross-platform within certain constraints, so long as your application can be reasonably put within an HTML page, and all of the data can be shown and displayed without having to use anything very super specific to perhaps a platform or to the phone. Then it would probably port quite well from one phone to the next. But like I said before, this is not going to be the panacea in order to create an application, any type of application for all platforms, just because there are constraints, and they're very similar constraints to what we saw when we tried to develop web apps for these mobile devices. However, what PhoneGap does is it exposes just a few more of the hardware capabilities of a device to an HTML page. But all of the other limitations of using HTML or using a web app to create our applications still apply. Any other questions? Okay, so I don't want to talk too much more about PhoneGap because David will actually continue talking about it in iOS. So for now, Android part really for reals is wrapped up. Thank you all for watching, and shortly we will begin again with iOS.
All right, so this is the strong finish here. I'll expound on some of the things that Dan looked at, but from an iOS perspective. But what I thought I'd do first is get our thank yous out there right away. So a big thanks to all of our team, to Tommy, to Alex, Bob, Chris, Craig, and JP, Larry, Joseph, Matthew, Philip, Tom, and Welly. Honestly, we went from 30 students last year to 250 this year, and if it weren't for that long list of team members on the board, certainly couldn't have done it. So many thanks to those guys in particular. So I think it's very easy to kind of lose sight of the forest for the trees now that you're actually writing programs on both of these platforms, as well as mobile a few weeks back. And many of you, like me, are probably into this app or that, whether it's Angry Birds or something actually more useful on your phone. And at least I tend to get into this habit of just thinking, okay, these things are fun, they're sexy, they're different, but they're really just an evolution of my desktop computer and my laptop. It's a little smaller, a little more mobile, but it's, you know, we kind of expected this to happen. And not to introduce this with too much hype, but I frankly, when I saw the video I'm about to show about one particular app that's available for iOS, it kind of blew me away because it really made me step back and realize, like, wow, there is really some amazing potential now that we have 1 gigahertz, 2 gigahertz in our pocket. We have GPS services. We have full-fledged 3D graphics. I mean, you can really, this at least, really gets my brain going as to what the world might be like in just another 5 or 10 years. So with that hyperbole said, let me switch over to this YouTube video and introduce you to one app that's available in the App Store called WordLens. me start this over. We seem to have a buzz here. So, thank you. I had nothing to do with this. So that's admittedly just a big advertisement that we just gave these folks. But honestly, it was this sort of transformative application that really just kind of blew my mind, because it's a very exciting thing, I think, to walk around some foreign country, put up some device in front of you, and really change the world that you're seeing. And I don't doubt that we'll see even fancier tools than this. Now, with that said, we're not quite there necessarily yet. If you download this app, it's like free to download, or maybe 99 cents. But where they get you is that you then have to download and install the language packs for $9.95. So, and supposedly too, these signs for their advertisement were very carefully chosen to translate well. As best I've read from various reviews, which are not as positive as my own enthusiasm was when I first saw the video, is that it does a per word translation as opposed to contextual translation based on full sentences. And so it works, you know, might get you by at on a menu in a restaurant, but if you're trying to read fairly important instructions like road signs, though you probably shouldn't be doing this anyway, you should at least beware. But I don't doubt, frankly, that whether it's this app or some other, we'll get there. And so there's some exciting stuff ahead. So with that said, so continuing along the lines of advertisements, I hear good things about these few other courses. And we actually got to know some of you last semester and previous years about these courses. But I just thought I'd toss it out there. Even if you don't actually officially enroll, know that these courses' content are freely available as open courseware, much like this course. So if you're curious about learning a bit about LAMP, Linux, Apache, MySQL, PHP software development, web programming more generally, feel free to check out or join us in the fall, or next spring rather, at Computer Science E75, available at cs75.tv. This one, for a lot of folks, might very well be a step backwards in that it's actually would generally be considered a prerequisite for a course like this. But nonetheless, there's a lot of self-taught people out there who'd like to go back and fill in some holes in their knowledge. So this is ostensibly a rigorous introduction to computer science, data structures, algorithms. We use the language C for about 70% of the course, so we spend much more time than we did in just an hour a few weeks ago. We also introduce at the tail end a bit of PHP, JavaScript, HTML, CSS, and SQL, so you get a pretty good foundation in a lot of things. And frankly, if you were struggling in this course's iOS half, particularly with Objective-C, but also C and pointers and all of that, it's actually a good, if intensive, opportunity to really kind of go backwards and then realize, wow, I really, now it all makes sense a few months later. And then lastly, this course has been on hiatus for several years, but it actually is still pretty germane. Years ago, I taught this course on XML and Java. It's essentially a Java programming class that looks at various XML-based derivatives like XSLT for transformations, XML schema, SVG, a whole bunch of XML-related stuff. There's a lot more to it that's interesting than just open bracket, close bracket. So even though this course isn't offered anymore, it's at cs259.tv if you'd like to at least self-learn at home. So it was actually wonderfully fun last week to see that this utility was released by a researcher to demonstrate that Apple and others presumably are actually tracking a lot more information than we might realize, or rather, even if we might realize it, you don't quite appreciate it until you see it visually. So this fellow put together a tool that searches your Mac's hard drive looking for the apparently unencrypted file that's storing, for any of us who have iOS devices for the past several months, months at least, all of the GPS coordinates of where you have been. And so if you've been reading Slashdot, TechCrunch, any of those tech blogs these days, you'll see that Apple's caught a lot of flack for this. But in fairness, the same issue came up about a year ago and even involved the US government, Congress, who made some inquiries, and Apple went on the record saying, yes, not only do we log this information, we also ship it back to our own servers. But the revelation this past week was that, okay, yeah, but you're also storing it on my own computer, unencrypted no less. And the fact that this was just so easily accessible to anyone who has access to or steals your laptop was certainly disconcerting for folks, whether for reasons of subpoena or privacy or the like. But I thought I would at least paint the picture more visually with my own data. So turns out over the past several months, I spent a good amount of my time in Boston, Cambridge, in the Northeast here. I visited Carnegie Mellon University a few months back, which is in Pennsylvania over here. Went to a conference in Dallas, which is over here. Spent some time over in San Francisco and a layover in Las Vegas. And sure enough, each of these bubbles represents the places I have spent a non-trivial amount of time of late. If you zoom in here, you can see that I spend most of my time not in Cambridge, but rather more downtown Boston, and then scattered in various places running errands and the like over the past many months. And so this was all I did was download this free software, run it, and within 30 seconds or so, I had all of this data. And then these are just screenshots from the actual application. There's actually an animation aspect to it. There's a timeline here where you can click and drag and see the map change based on day or month or week or something along those lines. This was actually kind of fascinating too. If you've ever doubted that I actually spend time consulting in and working in New York, here's my proof that I go back and forth to New York quite a bit. So Boston's up there at top right. I've spent time vacationing on Cape Cod, clearly. And I spend a lot of time going down to Stamford, Connecticut, which is where Amtrak lets off. Then Dan and I would usually rent a car because we both happen to work for the same company. And then down here is Manhattan itself. So it's actually fascinating. I'm quite comfortable disclosing all of these places I've been, but I'll leave it to you to decide if you'd like to poke around your own history on your own machine. But it's super easy to do, and probably a little troubling. But I hesitate to sound fatalist, but I think this is probably the future, and that we're all going to end up getting used to this, for better or for worse. All right, so back to this discussion of web apps and native apps with an iOS spin. So Dan introduced us to this idea of PhoneGap, and there are a few other such frameworks out there. PhoneGap does indeed seem to be the most mature and well-known, and it does have a decent track record now of people using it and their apps not getting rejected, for instance, by Apple's App Store, which is historically quite stringent, but many non-trivial number of apps have gone in. But that's at least something to be mindful of with Apple, where they exercise some judgment as opposed to the Android store, which is a little looser. But we'll talk more about the Apple store in just a bit. But let me toss the question out there now that you've had at least a little bit of exposure to the capabilities of using JavaScript to write web apps but have them work cross-platform. At this point in the semester, we spent a few weeks on web apps, spent a few weeks on Android, a few weeks on iOS. We're kind of coming full circle tonight. Which of them are you going to go with once you exit back and head to the real world? Yeah. Okay, web apps, why?
Well, if what you're doing is not intensive, CPU intensive,
okay.
Basic UI, I will go with that just because once you develop that, you can easily port it to.
Okay, good. So if you're doing something that's not particularly CPU intensive, you don't necessarily need OpenGL or Quartz 2D graphics, and therefore can be comfortable running in the confines of a browser window, then web apps are certainly a compelling option. Yeah? Okay. Going with Objective-C and iOS. Okay, so the vote here is for Xcode 4 over Eclipse, and Eclipse certainly has its ups and downs, but Xcode 4, it too, as we'll see one more up and down, or down tonight, overall is actually a pretty comfortable environment, I'd say. Yeah. Other thoughts from this side? Web apps versus native? Yeah. Yeah, so there, in terms of latency and responsiveness, it does seem that indeed when native apps have this more rapid feel, even if the data they're loading is the same, at least even if it's that split second, say 50 milliseconds here, users might very well notice that. Yeah?
I just say Android apps, because I sort of just like how you get access to everything a lot easier, even though PhoneGap is pretty compelling.
Okay. 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 Not having access to Macs as much, you mean, or? Oh, so that's actually an interesting mark in the downside column. If you're not 18, you cannot submit apps to the App Store. So good, gotcha. Yeah.
Yeah, I didn't really like this whole closed shop Apple thing. Having to have a certificate to install software on your own phone is a little obnoxious.
I agree. Yes, definitely in the downside column for iOS is the process by which you actually can use your own hardware. And I got a list of other potential downsides. We won't read them all, but we've linked to it on the course's website. So more in that in a bit. All right, so to each his own. And actually, the fact that we have a little bit of disagreement here is wonderful, because it means there'll be quite some variety of cakes and of apps at our app party on May 13th when we gather for one last time. So this is just a screenshot from PhoneGap's own website. You'll see on the lectures page for tonight, we've linked to the documentation and the downloads for PhoneGap. And this isn't to say you should use or want to use this particular one, but if you are even considering changing directions, albeit slightly at the last minute for your student choice, or for your HTML5 choice, you would be welcome to implement a PhoneGap or PhoneGap-like application for the extra credit we proposed for the HTML5 student's choice, because as Dan showed already, at the end of the day, even though there is a bit of Java and or Objective-C going on once you download the template, ultimately you're writing JavaScript code, and that's really the compelling aspect of it. And so what Dan showed on PhoneGap's website is that when you download PhoneGap, you're essentially downloading templates for each of these popular platforms, for BlackBerry, for Objective-C, for iOS, for Android, and for a few other platforms. And what they're providing is the native code that's going to allow users to have that icon on their desktop, and they're going to have some native compiled code running on their actual device. But what all of those platforms are ultimately going to do is open up the equivalent of a UI web view, a web page inside of the app where your actual JavaScript code is going to run. Yeah?
Another reason to go to staying native is that both Objective-C and Java are much better object-oriented languages than JavaScript.
OK, so the argument here is that both Objective-C and Java are better object-oriented languages. So I personally won't necessarily go there. I actually love JavaScript and think that you can do very elegant things with it these days, but to each his own, certainly. But to know that JavaScript itself is indeed object-oriented, and you can simulate a lot of the features that you might have explicitly available in Java, like public and private and all of this, even in that language, though we didn't spend much time on JavaScript in this class. Yeah?
Just a question to you. What about you? What is your take on?
It's a good question. What is my take? Personally, I think it's inevitable that we'll transition to something like web apps that aren't even wrapped in these silly little wrappers that you have to do for 5 or 6 different platforms right now. I think, and I'd like to hope that's where the industry is going, but right now, certainly with the hardware features that aren't currently accessible to JavaScript, I think that's unfortunate and is reason enough to use like a native app if you want that accelerometer or gyroscope or whatever it is that you want in the future. I feel like certainly the industry is young enough and these phones are young enough that it's going to take some time for the world just to decide what features do we want to standardize on. And if the habits of industry in the web world are any indication, I'm sure we're never going to get 100% agreement. But surely, I mean, as a computer scientist, this is a horribly inefficient way about going about implementing software, implementing it for this platform, and even PhoneGap, which is actually pretty compelling, I think. It's still kind of a hack to use this template code wrapping your other code. So I think in some number of years' time, JavaScript or some successor thereof is probably, I would like to think that's where we're going to be. And we can put down our Java and Objective-C and our native particular IDEs and use something that's a little more generic. We'll see. Yeah. Excellent question. Can PhoneGap be pointed to HTML not on the phone? Absolutely. In fact, even though the demo you saw Dan do and the one you'll see me do in just a moment is using an index.html file that's local, that's certainly not prerequisite. You can have everything be server-side except for the PhoneGap library, for instance. And even that library arguably could be server-side if you want to make sure it's the very latest version. So yes, the only downside of making a PhoneGap type application that really pulls from the server is that now you're introducing non-trivial latency issues. Whereas if you push all of your JavaScript to the client, at least then it's running locally and would be zippier. So that would be the upside and downside there. So here's the chart that Dan actually alluded to. And this, too, is very easily findable in PhoneGap's own website. But you can see just from the colors here, it's imperfect, right? You can't do absolutely everything on all of the platforms. Green check means that something's supported. So this is, for instance, the iPhone 3GS and later column. The green checks means it supports accelerometer access via JavaScript, the camera, the compass, contacts, but not the local file system. Yes to geolocation, kind of, sort of to audio recording, and then yes to these other things. And similarly, can you look through the chart to see what's available on these other platforms? And to be clear, that's what PhoneGap and similar frameworks are doing for you. They're giving you a handful of JavaScript functions or methods that you can call, and they've taken care of the busy work of figuring out how to get that JavaScript code to talk to Java or to talk to Objective-C in the native environment. So that's actually a good segue to what actually is the answer, but it's sufficiently arcane here that maybe I can still ask the question. How do you actually get something like a JavaScript library running inside of Safari, a UI web view on your native iOS device, to actually talk to Objective-C, to actually talk to the hardware like the accelerometer? In other words, how do you go about implementing something like PhoneGap, do you think? Yeah, it is in fact the UI WebView delegate. I thought there was one more question slide before this. So there are indeed ways where you can get JavaScript to talk to Objective-C in some sense. And one of the answers to that problem is this thing. This is a protocol. We've talked about these certainly. This is a protocol that relates to the UI WebView. And for those unfamiliar, if you haven't seen in Section or in your own student choice projects, UI WebView is just another UI view you can embed into your actual native application and then load URLs into it because it's essentially an embedded browser. So UI WebView delegate is nice because UI WebView objects implement this protocol. And so anytime new content is loaded into a UI WebView in an iOS application, this method in particular is called. WebView should start load with request navigation type. So another verbose one. But what's nice about this method is what's passed into this method as one of its parameters is the URL that the user has visited inside of this embedded web view. Now that's kind of interesting. And those of you who are pretty comfortable now with JavaScript or remember at least our couple of weeks in this course, you might know that you can change the URL in a web page by doing something like window.location.href equals something. So you programmatically in JavaScript can change the URL that appears in a browser, whether on the desktop or in a mobile environment or in a UI web view. So it stands to reason that if you can change the URL in a browser to anything you want, you can then pass data to Objective-C, specifically to this method, by, in JavaScript code, changing the URL in that embedded web view, because then this method is automatically going to get called by definition of Apple's UI web view. And so this Objective-C function can then look at the URL that was just passed in to the embedded browser and do something with it. Now, what can you do? Well, the approach PhoneGap has taken is this. In the JavaScript library that they've written, that you get to use, they have implemented a low-level detail that does this. If a URL of this form, gap:// is put into the URL field of a UI web view, that previous method on the previous slide, as part of that protocol, gets called. This gets passed in as an argument. And the Objective-C code that the PhoneGap people wrote for you is to parse this URL and to see, oh, this is not HTTP://, so I'm actually going to do something. I'm going to specifically pluck off the first keyword before the period, and I'm going to assume that's the class of functionality that the user wants to use. Maybe it's accelerometer, compass, something like that. .command, I'm going to assume the thing after the period in this URL is the name of a method the user wants to call, the JavaScript programmer wants to call. And then after the slash and or question mark, I'm going to have a whole bunch of key value pairs that I'm going to consider to be this Objective-C method's arguments. And so if we go up to PhoneGap, this is the documentation Dan had up before. It's broken down into all of these classes. And so you see capital accelerometer, capital camera, capital compass. Those are the class names. So that what PhoneGap did is anytime you call one of those accelerometer functions that Dan showed, albeit in an Android context, they say, oh, that Objective-C function says, oh, starts with gap://, so I should care. I'm going to keep parsing this URL. Oh, I see the word capital A, accelerometer, that means I'm going to have to go into my Objective-C code and find the accelerometer class. What method do they want to call? Da-da-da-da-da-da. And now you know which Objective-C function to call. So that's how you can call Objective-C code from JavaScript. And now what about the reverse direction? Well, it turns out that Apple has provided inside of the UI WebView class itself another verbosely named function called string by evaluating JavaScript from string. I don't know why they couldn't have simplified that. But it takes as an argument an NS string. And if you put a whole bunch of JavaScript code in that NS string, so literally open bracket, script, close bracket, and then foo equals bar, whatever code you want to write in JavaScript, you put that into an NS string, pass it to this method to the UI WebView that is embedded for you in the PhoneGap application. Voila, you can now call JavaScript code from Objective-C, albeit a little hackishly, by simply creating a string of JavaScript, passing it to this method, bam, it gets executed. Now, we, the normal people, don't have to actually worry about all of these low-level details and/or hacks, because as we saw even with Dan's Android application, it's all abstracted away for us based on these JavaScript methods. And what the PhoneGap folks have done for us is figure out how to do something like this on iOS, something like this on Android, on BlackBerry, and on those other platforms still. Yeah? What is it doing? No, so how is Objective-C figuring out what class to call? So it's literally parsing the string, and it's going to see A, C, C, E, L, accelerometer, and then it's going to instantiate a class based on that name. And you could do this with any number of ways, right? You could do string comparison, you could use a switch statement, you could instantiate it dynamically. In short, it uses that to instantiate, if needed, the right class. But it's nothing fancy, really. It's just looking at the string that was embedded in the URL representing the class name. Yeah? Mm-hmm.
And then call those classes from the JavaScript?
It does. So that's actually a really good point. You could indeed borrow the same principle and write your own Objective-C code and make it accessible to JavaScript by, frankly, taking the PhoneGap template and building into it, or just borrowing this idea and using your own URL scheme like we saw before, and then implementing exactly the same kind of workflow. So absolutely, yes, this is possible. Things only break if, for instance, Apple deprecates this method and or the other one. So right now, though, it works just fine. Yeah?
I'm assuming you don't get native UI widgets with this?
True.
JavaScript and HTML for the UI?
Exactly. So you don't get anything for free here. There's got to be some price we're paying for this beauty of cross-platformness. And indeed, you have to sacrifice native UI widgets like all of those UI pickers and UI rounded rect buttons and so forth. Instead, you would go back to, if you think back to weeks 1 to 3 in this course, you would use something like Sencha Touch or JQ Mobile, or jQuery Mobile rather, and use HTML-based widgets with CSS. Good question. All right, so PhoneGap and Xcode 4, our old friend. Doesn't exactly work all that well. So here's the other price you pay. So when you go to PhoneGap.com, as Dan said, you can simply click this orange button and download that folder. And inside of that zip file are an iOS folder, Android folder, and inside of those are are essentially installers. You double-click the one or the ones you care about, you get it going. And what it should do, in theory, even according to their current documentation, is if you then load up Xcode and go to the familiar create new file, create new project window that we've used many a times, what you should see, and what you'll see in the documentation, is that besides the iOS applications over here and macOS applications over here, you'll also see another row for PhoneGap application, because all it's doing is installing a whole bunch of Objective-C and JavaScript and HTML files and folders into the local file system so that they show up as a template. But apparently they haven't gotten around to doing this correctly yet for Xcode 4. So instead, what we've provided you with, because it does work, and we'll see a demo in just a moment, do not overlook on our lectures page for tonight the 3 links we've provided to community forum discussions on exactly how to create a project when it doesn't actually appear in that menu there. so our links aren't responding quite here at the moment. But essentially, there's some nice discussions out there. It's not hard. You end up running a command line script in your terminal window. That then creates a foo project, for instance, on your desktop or wherever that you can then open. And so let's now continue the conversation there. Pretend I did that and installed the command line script and ran it on my computer. I would have a project called, let's say, PhoneGap. I would go ahead and open the Xcode project file as usual. And then it would appear here. And if you build it from scratch, I don't mean to poke too much fun, but this is really frustrating fixing all these bugs. You then get like 4 build errors. So then you read the other community forum posts that we've linked to on the lectures page for tonight. And long story short, you get an application then that you can compile and run in the simulator and or your actual phone. As an aside, you can't like shake your laptop up and down and get the accelerometer in the simulator to work. So you're going to continue sacrificing certain testability inside of the simulator. So best to really leverage something like this if your own hardware supports it. If this is all very disappointing and now turning you off from doing any extra credit whatsoever, also posted tonight is a zip file of my correctly configured project that has very little boilerplate code that I wrote, so you can assume that as a starting point if you would like and avoid most of the issues I ran into. So why don't we take a quick tour of what's actually in here, at least in Objective-C. So the font's a little small, but most of this stuff on the left-hand side here is familiar. Let's go from the bottom up. So they have gone ahead, the PhoneGap folks, and gone through that annoying set of steps for adding libraries to the linking process. And so they've added in things like core location, media player, Quartz core, because the whole point of this library, of course, is to expose all of that functionality to you. So they've simply gone through the steps of actually making those frameworks, those libraries available to your project. Scrolling on up, you'll see a bunch of resources. And these could be organized, frankly, in any number of ways. This is not necessarily standard. This is just the way they chose to lay things out. And there's an icons group here with the program's icons. You'll see on my phone in a moment that the default icon just says PhoneGap, but you can change that to be anything you want. You see things like a property list here. There's some other pings there for the splash screen that appears. So if this is a little bit overwhelming, honestly, you can ignore most of this stuff and only start to tease apart what all these files are when you actually have a problem that you want to solve, because there's relatively few files that you even need to care about. Now let's take our typical tour. At the top of this listing, there's main.m. Well, that actually looks like it always does. There's no changes there. At the top, you have PhoneGap appdelegate.h and .m. Those two have some functionality for handling things like low memory situations and termination and the like, but that is pretty much the boilerplate Xcode template code. So really the interesting stuff is not happening in these files, but rather inside. Let me just scroll up a little bit. What's really happening that's interesting is in this thing. So you'll see that what's embedded inside of this project is another Xcode project, namely the PhoneGap lib project. And if you get curious, PhoneGap is entirely open source. So even if it's just an intellectual curiosity, you can certainly read through all of the code and see how they actually implemented these low-level details that we discussed here pictorially. But inside of there, well, you see a whole bunch of .m and .h files that collectively implement this thing called PhoneGap. And in there is classes, commands. They've laid things out in fairly nicely organized form. But if you don't care about how it works, you just care that it works, the only file you really need to give much thought to is index.html. So we've kind of regressed back to week 1 or 2 here, in that we can focus only on the web stuff. So sure enough, let me go to index.html. As Dan mentioned before, the file is called phonegap.0.9.4.js right now. And then over here, we have the boilerplate HTML. So let's take a quick tour of what's going on here. So in the head of this page, we have the familiar and boring things like the HTML title and some meta tags. Those are probably old school right now. There's an opportunity here to uncomment some mentions of CSS style sheets for iPad and or iPhone specifically. So you don't have to figure out how to parse the user agents and figure out which one is which. You can leverage the work that the PhoneGap folks have done for you. There's a mention here of how to make this backwards compatible with older versions of iOS if you really want. And then down here is where you get to start writing your code. So here's a script tag. And down below is some commented out, some actual code that you get to write. And so the function that really kicks this off is this thing here. There's a JavaScript function that they give to you for free called onBodyLoad. Notice it's adding an event listener to, quote unquote, for the device ready event, which means the phone is now ready to start processing JavaScript. and it's passing in a couple of arguments, but we can wave our hands at those here. The actual function is called onDeviceReady, and now what does this demo do? I'm actually a little disappointed. Dan's demo is much cooler and more annoying than mine. Dan's, recall, resisted your attempts to turn the text upside down, or right side up rather. Mine just shows you the compass, which now feels kind of a letdown. But that's OK. Let's tease apart how it does work. So this is actually adapted mostly from PhoneGap's own documentation. So if you want to actually see the origin of this, though I did make a couple of corrections. So startWatch is just a function that's defined right here. Well, what does it do? Well, we have a JavaScript object here specifying a key value pair of frequency 500, implying 500 milliseconds. I'll fix that. It used to be 3 seconds, but I made it faster. Then we're using, here's the PhoneGap stuff. So as Dan mentioned, they have added to the global navigator object via its prototype property a property called compass, and changing its watch heading function and passing in these 3 arguments: onSuccess, which is a function pointer to a function called onSuccess, which is down below the break here, onError, which is another function, and then options, which again is this object here. So this is the function that, were you not using something like PhoneGap, wouldn't have access to. You cannot access the compass on iOS otherwise. Now, if we scroll down as to what these functions are actually doing, stopwatch is uninteresting. It's just going to stop the counter. So let me wave my hand at that and look at the juicy stuff. So what do you do on success if you're actually able to talk to the compass and get back a directional reading, north, south, east, west, or something more precise? Well, we're going to call document.getElementById, quote unquote heading. Now what is that? Well, let's look. Oh, this is nice. Very little HTML here. The only HTML I really have is a div and an ID of heading, and then waiting for heading, ... and then 2 HTML buttons, both of which trigger, when clicked, those 2 JavaScript functions to get called. So there's a start and a stop button just in case you want to turn off the compass. So what I'm doing here is getting that element called heading. I'm then changing its inner HTML property to be heading : and then this thing here, heading.magnetic heading. So this is the return value that's passed into the onSuccess event handler. This is the property that I actually care about. So here, too, is one of the things I learned the hard way. If you read the documentation at the moment, they say that heading is just a floating point number, which is the degrees from 0 to 360 that you're actually facing. Not so. At some point along the way, they changed the number to an object that contains multiple fields. So I just poked around the object to find the one called magnetic heading. So realize, yet again in this class, we're a little cutting edge. We're kind of using these things slightly before their time. But the end result is this. Let me go ahead and switch over to our document camera. Let me go ahead and pull up this application, which was burned to my phone via a USB cable. It should brighten up in just a moment. And you'll see very simply at the top, waiting for heading, ... start watching, stop watching. Now what are we actually looking at? It's a white background and it's a rectangle. Well, that's because the PhoneGap template essentially said the only thing you should do in Objective-C is create a UI web view and make it fill the UI window that we were given. So now we are running the equivalent of Safari inside the window, though it's not quite full-fledged Safari. I'm going to go ahead and click Start Watching. That means every 500 milliseconds, that JavaScript function is going to get called. It's going to talk to the compass by way of this phone gap between JavaScript and Objective-C. My phone's not moving, so apparently that is 220 degrees. If I go ahead and turn this thing around, it is indeed turning. This is sort of the poor man's version of the compass that is much sexier that actually comes with the phone. But now I'm pointing essentially the opposite, 17 degrees, so it indeed works. And if you're underwhelmed by the UI, at least realize that this would not otherwise be possible to talk to this hardware within the confines of a page. And what's nice, too, if we actually connected up an Android phone and burned the same code to this thing, this same exact JavaScript code, in particular that call there, navigator.compass.something, would still work, because PhoneGap has taken care of the cross-language communications. Question, yeah?
Can you not get rid of the status bar?
Can you? Oh, no. You could get rid of the status bar using a meta tag, because you're still talking to mobile Safari in this case. And there would be, so yes, we could. Sorry?
No, the bar that was there visible, actually, you can't get rid of regular HTML. One would think that PhoneGap.
Oh, correct. Yes. No, you can do that using, let me pull it back up, the no service and the 1854. You could do that using the trick that I think I used last week or 2 weeks ago for the Tommy app, where we remove the menu bar in the.
Leave that. I'm talking truly full screen.
Oh, you can get rid of that too. Not in your JavaScript code. You could do that in the actual template, in the Objective-C template, by changing the certain property list.
Oh, because
That's part of the wrapper right now. PhoneGap has left that enabled for iOS. But we could remove that. Yeah?
It's not really like Java that you can just take one executable and put it on different phone operating systems. You really have to run it on two different, like you have to run it on Android to get its packaging.
You do.
Export to get its packaging.
Correct. So it's not quite as simple as it might seem at first glance in that right now I'm just targeting the iOS platform. If I also wanted to target those other platforms, I would have to go into the PhoneGap folder, run the Android installer, or drag the jar file out, set up an Android project. And now at this point in the story, it gets a little messy because if you start copying your index.html files around or your image files around, now you have to keep all of these various projects in sync. However, you can ameliorate that concern by putting your shared resources, your HTML, your CSS, your JavaScript files in one folder on your hard drive and having both projects, both Eclipse and Xcode, point to that exact same folder. But it's more to keep track of. It's not as simple as just saying, make this for all of these platforms. And now with that said, let me try to head off what might be a comment here, because I know it's coming. With that said, PhoneGap has now, I think it might still be in beta status, a cloud service whereby you actually upload your resources, the HTML, the JavaScript, and the like. And it might not be fully public right now, but the idea of that service is they will burn all 6 images for you and return the binaries to you. Oh, I headed off some of those questions. OK, yes?
So you said a moment ago that this actually does cooperate pretty well with like Sencha Touch and other libraries.
Should, absolutely.
There's actually a list of the libraries that they integrate well with, and one of them is Sencha Touch.
Yeah, because at the end of the day, you're really just running a browser window. So almost anything that we did in the first weeks of the course should, in theory, work in this UI web view, with perhaps a few exceptions. Yeah?
How would you be able to change the template, the actual Objective-C UI to remove that part?
Oh, so there's so many places to tweak some of these things. But if I go to the project here, click on, nope, not here, info plist, PhoneGap info.plist. All right, so I'm in this file, which I think we brought up a week or so ago. Let me create another row here. And let's scroll down. Status bar is initially hidden. And then you would change this. It's a Boolean, so you would change that to yes. I don't have my USB cable here, but if I then recompiled this project, put it onto my phone, then we would indeed have quote unquote full screen with this application too. Yeah?
Are all the hardware, looks like the numbers and everything accessible if you're loading data from the internet, like the JavaScript and HTML that you're dynamically loading?
Good question. Is hardware accessible even if you're loading data from the internet? Yes, because you can pass from your own JavaScript code the data you've gotten to these Objective-C functions by way of the lower-level gap : / method. You would have to, yes, you could write certainly your own methods that support that you'd leverage that same cross-language communication. Yes. Yeah.
How do you debug applications in PhoneGap? Can you set breakpoints that act within the JavaScript?
Good question. You cannot set breakpoints within the JavaScript code in Xcode. What you would generally do here, it's a good question. How do you debug applications here? So you can certainly set your breakpoints in the Objective-C code. That would at least reveal what methods you're calling of the hardware, because you could intercept, for instance, 1 or 2 of the methods that we discussed in the context of UI WebView and UI WebView Delegate. On the JavaScript side, you're essentially still writing a web application. And just as in the first weeks of the course, you might have used location services in a browser, and sometimes on a desktop computer, it just doesn't return, or it just returns null. You could still use a tool like Firebug in your actual browser and debug your application there. When you actually need to start getting back values from like the accelerometer, and you're doing this now within a desktop browser, best thing you can do there is to simulate the answers and have a little wrapper function that temporarily always returns true or 1 or whatever, or some random floating point value. So it's a little clunky, a little hackish, and in fairness, this is not what Xcode itself was designed for, but it can be done. Yeah.
You mentioned that the way to access those low-level routines classes is gap : / and then the class followed by the name.
Okay.
You didn't really use it. You used it through the navigator to access the content.
So correct. So let me correct the impression I gave. Academically, we discussed the gap : / protocol as to how PhoneGap works. We now, as the developers, do not need to know or care that I ever said that. You don't even need to know how this underlying JavaScript to Objective-C and back mechanism is working. The only thing we, as users or developers that are using PhoneGap, have to care about is this stuff here. When you've downloaded the Objective-C template and have started using it, the only things we should care and know about when writing JavaScript code is what's publicly documented here. The fact that it's implemented via that clever and or hackish URL-based approach is really an underlying implementation detail that we should not even care about, because it could change, but it's also incidental to the API. So you need never use those URLs unless you're rolling your own functionality that doesn't come with PhoneGap. Yeah? Yeah. So actually, short answer, yes. So that would be a really nice application of this idea of adding your own functionality. And I'd have to poke around. I don't know if there's anything publicly exposed right now in PhoneGap, but the forums might reveal. But you could certainly implement your equivalent of NSLog in JavaScript and make sure that it calls via this URL-based mechanisms that we've discussed, but we really shouldn't be discussing, so that it calls the equivalent Objective-C function that you can set breakpoints in your Objective-C environment, namely Xcode, and then effectively walk through some of the code that way and see what's going on. So that would work too, sure. All right, so an option to consider, especially if now you've spent the past couple of months playing with both of these environments and now really aren't sure which of them to choose. So how about that App Store? So this is the thing that we encouraged you not to spend $99 or $299 on accidentally, because at least for the course's purposes, you don't need to. But if you're super proud now of your iOS Student's Choice project, or if you use something like PhoneGap, your HTML5 Student's Choice project, or if really you just want to start selling Evil Hangman, you're going to need to actually pay one of those entrance fees. Generally, individual developers would pay the $99 fee. People with companies or multiple business partners would pay the $299 so that you can share code more easily among each other. And we won't dwell too much on these details, but at least just to give you a mental picture of what's involved. As you might have inferred, if you've actually registered with the course, your iOS device, there's this thing called the provisioning portal. It's a web page that you go to, you log in with your Apple ID, and then you can then upload your certificate, you can download your quote-unquote provisioning profile, and the provisioning profile is essentially a file that combines your certificate and our digital stamp thereof and your device's unique ID, so that your phone is then authorized by Apple to actually run that particular code. Now there's this process here. This picture is excerpted from Apple's own documentation, but if you've used that interface already just for yourself, just imagine now letting friends or colleagues download that same provisioning profile onto their own phone, and so long as system administrators like us, in the course's case, have said, yes, devices 1, 2, 3, and 4, 5, 6 are allowed to run this program, well then 2 of you or 3 of you or more of you could actually start sharing the same application within your company for testing purposes, or even if it's like an internal application that you really don't want selling on the App Store, but you wanted to develop a tool for your 50 employees to actually use internally, you could use the same mechanism to do that. But I would refer you to the official documentation if you need to do that. As to submitting to the App Store itself, so this is that thing called Organizer, which keeps cropping up, it seems, with some extra functionality, and one of them is this. There's a process by which you can archive your application, create a bundle of sorts for it, and then if you open up the Organizer and you have access to the provisioning portal in this way, there's this button down here, Submit Application to iTunes Connect, which is the web-based UI via which you can keep tabs on what you're earning on your app, if people are buying it, whether it's approved or not, or if it's been rejected, and a whole number of other things. This is just a screenshot of what you'd see if you logged into iTunes Connect with your own Apple ID. Right now, we're not selling any applications, so there's not all that much to see, but it's a web-based tool with which you can manage the wares that you are selling and perhaps the money that you are making. It's worth noting, though, before you spend a whole lot of work on your student project or after the course, there's 8 pages of guidelines as to what not to submit to the App Store. I would at least at some point skim these. The tone in them is actually quite remarkable. I thought I'd just read a few excerpts and then also some obvious ones, or maybe not so obvious ones, since we certainly occasionally get project submissions that still have little yellow warnings and sometimes red flags. If you're disappointed when we notice those things, you're going to be really disappointed when Apple notices those things and doesn't even let you in the door. This is the document that's available once you've registered for an account here, and it opens with, let's say, well, here's how the story starts. We view apps different than books or songs, which we do not curate. If you want to criticize a religion, write a book. If you want to describe sex, write a book or a song or create a medical app. It can get complicated, but we've decided not to allow certain types of content into the App Store. It may have to keep some of our broader themes in mind. Quote unquote, we have over 350,000 apps in the App Store. We don't need any more fart apps. If your app does... I think it's hilarious that these are the official guidelines. If your app doesn't do something useful or provide some form of lasting entertainment, it might not be accepted. If your app looks like it was cobbled together in a few days, or you're trying to get your first practice app into the store to impress your friends, please brace yourself for rejection. We have lots of serious developers who don't want their quality apps surrounded by amateur hour. Let's say, if your app is rejected, we have a review board that you can appeal to. If you run to the press and trash us, it never helps. And then the last bullet in the introduction, then there's 7 more pages. This is a living document, and new apps presenting questions may result in new rules at any time. Perhaps your app will trigger this. More down to earth, though, is the more categorical constraints. And some of these should go without saying. And this actually is worth a read if you are serious about submitting something to the store. Better to keep in mind some of these constraints or gotchas beforehand rather than be disappointed after months of effort. Under functionality, apps that crash will be rejected. Apps that exhibit bugs will be rejected. Apps that do not perform as indicated by the developer will be rejected. Apps that use non-public APIs will be rejected. There's a whole number of them. So some of them reasonable, but definitely someone was in kind of a bad mood when they wrote this document the first time around. So that is the Apple App Store, and you can check those out at the URL here. So, quick reminder, the app party is a couple of Fridays from now, 5:30 p.m. in Maxwell Dork in the Computer Science Building. We're going to have some distant students, those of you who've been following along at home, joining us, as well as the staff. It has been a pleasure having you in the course with all of us and the teaching fellows. So many thanks, and I'll stick around for questions tonight. Otherwise, we'll see you in a couple weeks.